Now, finally, we go from the Google for DITs to the dark, deep bottom of wallets with Christopher Allen. Chris, stage is yours.
Okay, so what I really want to talk about is the bottom of your wallets. I mean, right now, almost all of these wallets are hot with hotkeys, oftentimes run in JavaScript, not at all timing attack resistant or other side channels. At best, you have a little bit of support from maybe one of these, this is a ledger, which is a 2-chip solution, which basically then executes all of your cryptographic operations in MicroPython and something that could be supply chain attacked. I can basically put this one in yours and pull this one out, et cetera, and you'd never know. So Blockchain Commons is really working at the very bottom, underneath all of your wallets, to try to create some interoperable standards for how we handle a lot of the cryptography and seeds and things of that nature that's below the levels of all the stuff that you've seen so far. To a certain extent, we're trying to solve this classic XKCD problem, which is we're all relying that somebody else is going to do that little bit at the bottom to make it safe for us. And we don't want that to happen. We don't want that to get knocked out. So we've been working with silicon vendors at the bottom. We've been also working with new emerging companies. This is a $250 air-gapped wallet, has a camera on this side, has a color screen on this side, supports a number of the Blockchain Commons standards that I'm going to demonstrate to you in just a minute. They will be coming out with a version of this in which you can own. Right now, this is using their firmware. They'll be coming out with versions that you can use your own firmware for it. And I highly recommend you go look at this site for the video on how they're securing this and how they're doing supply chain security and doing all the different things there. But we're also working with new chip vendors that are trying to offer SecP, BLS, other future cryptography here. So, we've been talking a lot about QRs and the perils of QRs, and there are definitely a lot of perils. One of the things you will see in almost all of these different types of things, whether or not it's this QR or some of these things on my iPhone over here, are these life hashes. So life hash is something you use in addition to all of those hexadecimal numbers that I've seen in a whole bunch of the bottom of your screens. Right now, you really can't rely on that. It's not too hard because most people are either going to look at the first 3 digits or the last 3 digits or whatever, and they're going to say it's the same. They're not going to compare it against it, et cetera. A life hash is designed to be readable in a wide variety of formats. So if you go to lifehash.info, you can just type in RWOT, and you will see live that there is the life hash for that text. And we've run it through lots of different types of things. It's a very deterministic, and yet a single bit will do massive changes in how you're doing it. It shouldn't be used by itself. Obviously, you know, I can probably program a stable diffusion thing to do some magic, but the combination of the partial hashes that you're already showing, and this is a very strong thing. So why is that important? So one of the things I can do here is that I can scan this image, and boom, it tells me, guess what? Now, can you from there see that this must be the same thing? What was sent to me is what it was promised right here. So that's an example of a way to use LifeHash. If you wanted to use it with regular QR codes, you could basically take the payload of the QR, put the image beside it, and try to create a standard where everybody basically first checks the LifeHash to see it actually is what it's promised to be. We've also been, that's why I knew a little bit about this other thing. We've been thinking about other methodologies where maybe, so for instance, this isn't actually the hash of the QR because it knows that this is a seed. This is the hash of the public key. So so we're actually looking at a subset of the data for that to render that particular image. How am I doing on time?
Okay, 2 minutes.
Okay. So we have this. We've also been working on on SSKR, which is a Shamir secret recovery standard. So you can see here that I have given to maybe several of my friends these little fragments. Once again, I can scan. I will scan this one. And you'll notice here that it's saying, hey, I recognize that this is a simple QR. I need to have at least one more. I have 3. This is happens to be a 2 of 3. And I can very quickly go here. Boom. Guess what? I've got the same seed. Once again, the QR code prints fine. We've also rendered this on a black and white 200 by 200 screen using dithering. So it's really, really small, and it's still quite recognizable. It's really designed for that. So once again, I've confirmed what I gave somebody is what I actually ended up getting returned in an SSKR. Future things we're working on, I have some examples of this using NFCs, so you can recover with NFCs. We also can sign this data, so you could have a QR payload that is signed by the issuer that is separate from the certifications that might be in the payload, such as a verifiable credential. So if you're interested in these things at the bottom of the stack, we have regular meetings. The big project this quarter is to have people cooperatively store seeds. So if your company goes out of business, there's another company that is storing shards, not the whole seeds, shards, so that in the absence of your company being able to work with your customers can recover. So we're all mutually helping each other with seed management. That's it.
Thank you, Chris. And now the final round of questions. Yeah. We start with Martin and then over to Jack. Martin.
Did you think about combining the QR code with the live hash? That should be visually possible, and then
we've looked into that. I mean, just to give you sort of one of the other standards that we're working on right now. It's not as easy as you might think. This here is probably our most successful standard, which is only used in the Bitcoin world right now. But this is to deal with the problem of PSBTs being far larger than what are possible on a QR code. So we basically are doing this rendering that'll then allows me to have a full transaction partially signed. If I right now scan this, so it basically now is saying that this is a signature request, and you can't really see it over here, but this is a signature request. No seeds on this device can be used to derive keys that sign this transaction, et cetera. So there's this, this is just an example of the kinds of things that we're trying to solve. So we weren't able to, we're also dealing with the fact that laptop cameras are really bad. And we end up not being able to do as dense QRs, whereas with this particular animated QR, we've done like a terabyte transfer using that between 2 phones, and it's actually not as bad as you might think. It's obviously, several orders of magnitude slower than an SSD, but it works. But only between 2 iPhones or 2 Androids with high quality cameras.
Do you support the BIP39 split mnemonic standard?
We do. I'll give this to you. So we support we support it indirectly. So we both wrote. They basically participated in our Barcelona and Prague workshops. The SLIP 39 or BIP 39? I'm sorry, maybe I'm confused.
Same. Like they're
Okay, so
roughly
BIP39 is
similar.
a single key recovery. In the book that Shannon and I wrote on smart custody, you write your single key on titanium so that it can survive a California wildfire, all that type of stuff. That's not good enough for multi-sig and a lot of these other different emerging technologies. We do SSKR, the underlying crypto is the same as what is used by SLIP39 from Trezor. The difference is they made a decision that there is no round tripping with SLIP39. Once you use their SLIP39, you're locked into, you can't go back to a BIP39. So you can't restore the seeds. It's all one way, all the way around. Whereas I can basically choose, I can either use the SSKR of this when I restore it, and then maybe I'm moving to a new device that doesn't support SSKR, and I can just use the regular BIP39 words. So we want the round tripping. We want reliability, no single points of failure,
And
no
do you
single
support-
points of attack.
And do you support different derivation paths as well?
Yes. Didn't have time to show it, but the free app, this app is free this week, so don't buy it, or you can buy it next week and give us $5. But there's a developer mode on it, and it has something called crypto request.
Yeah.
So you can basically say, you choose the seed, I want this particular derivation, and we support all the standard derivations. And then in this dialogue, you will note that, it's not on this one, but in a crypto request, it will tell you this is a known derivation, and or gosh, this is kind of weird. This might be safe. To be clear, this app is very much intended to be, a reference for these types of things. It does not assume a network connection. It can run offline. So it's not going to confirm Bitcoin transactions. It's not going to go out to the sovereign indie servers to do things. It's intended to do the crypto safely and separately.
So the app is Seed Tool, and it's iPhone only right now.
iPhone and Mac.
And Mac.
Yeah, so my question was if this is mostly, let's say, a research exercise, or if you're actually targeting a specific class of potential users. So are you planning to take over the people that today use the hardware wallet, or who are you targeting? Like, who would be using a solution like this?
We're representing a community of developers, so we are a not-for-profit. This is not intended to be a for-profit product. Instead, this is a reference for other companies to do this. So we already have about 8-9 developers who are doing that PSBT animated, ranging from these guys use it, a couple of what I would call second-tier wallets. The top cryptographic wallets are hardware wallets, are Ledger and Trezor, and they're kind of going their own way. I have no idea if they'll, but sort of the second tier, they're coming together and helping define requirements, and we're helping them coordinate to make these standards. Most of our financial patrons are cryptocurrencies. So NFT wallet, a biometric ring that you can tap it to do your Lightning transaction, some layer 2 type of wallet functions. So that's who our current financial base is from. But the intent, and that's what I've started really promoting here and in the last couple of months, is we need more identity wallet vendors who really care about the security at the bottom, so we can define the requirements as we write all these libraries. So all of this is open source in a variety of different formats. We also are getting security reviews done on them. We have a lot more to do.
This is awesome. I wanted to start using it right away. I think the last thing you mentioned supply chain attacks, and so my question is does this have reproducible builds?
Yes.
And
Okay.
how do I
So excuse me.
verify
You can't do reproducible builds with iOS. All of our apps have versions of the tool available for command line tools, and some of the base command line tools are reproducible builds. So, but it's one more step, but it's all available. One of the things we've been more concerned about is reproducible crypto. So all of our apps have the ability to turn on a deterministic switch, which makes the randomness not random. So you can make sure that the app that runs on the iPhone will give the same results as say the app that runs on LeafyKit. LeafyKit is a little Raspberry Pi-ish device that has no networking, no Bluetooth or whatever, and they'll give the same results, the same life hash for the same values. So we've been more focused on that than sort of a lot of the niggly details of trying to get everything we do be reproducible builds.
And it sounds like you're saying also like no iOS app is going to give me that property.
No, because you have to change the app it gets changed when Apple has it. Apple might be able to do it, but we can't.
What's the wallet name or manufacturer?
Oh, yeah, this is foundationdevices.com, and this is Passport is the actual this model. But we also have Proxy is coming out. I'd hoped they were going to be here, but they're trying to finalize it. They're going to have a biometric ring fingerprint sensor when you put it on, unlocks the ring kind of like an iPhone does, and then you can do things like tap the ring against surfaces or whatever for various kinds of yes, I want to confirm, yes, I want to do that, I want to have authentication, etc. So we have a number of different companies.
So this was Rebooting Web of Trust 11 demo night, live from The Hague in Netherlands. And we saw a huge variety of different demos, from dark deep wallet to the Google for the DITs, to credential rendering, trusted issuer lists, to universal resolvers, the entire variety of all the technologies being developed in the Rebooting Web of Trust community. And yeah, glad that you joined us, and looking forward to connecting with you guys soon. Thank you and take care.